Hey guys, Mr. Mailhot here for Bridge to College Math. Let's do some dot patterns. This is kind of our bridge between expressions and equations. This is from our homework, Sequences and Equations Revisited. Let's do number 2. So these dot diagrams show the beginning of another sequence of patterns. Take a second to look. Okay. It doesn't ask us to draw the next one, although we probably could. It looks like for sure there's going to be 4 corners. That'll be those black dots. How many white dots would go in between those? Well, this one has 1, 2, 3, 4. This one has 1, 2, 3, 2, 1. So 1, 2, 3, 4, 5 in between the white dots. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hopefully you already maybe noticed a pattern between the n, the value of n, and the number of white dots around the side. Yeah. I guess in the middle is just all black dots, so 5, let's see, we don't have to do this, so I'm going to do a real basic version. Whatever, you get the idea. The challenge here is come up with the equation. I think it's usually, in my mind, it makes a little more logical sense to start with the total and then work backwards, but we could go anyway. I'm gonna start with the total though. So total, a good way to look at it is, what are the dimensions? So for n equals 1, for the first pattern, it's a 3 by 3. N equals 2, 1, 2, 3, 4 by 4. These ones happen to be squares. They won't always be square patterns. Like, shoot, if you look at the last one, it wasn't always a square. This one is a square, though, each time. N equals 3, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. 5 by 5. 6 by 6. 7 by 7. For n equals 5. I think you probably noticed the pattern. The length of a side is 2 more than the pattern number. So if n is 1, the side is 3, or n plus 2. If the n is 2, the side is 2 more than that, or n plus 2, n plus 2, n plus 2. So the total number, a side is n plus 2, 2 more than the pattern number. But since it's a square, we gotta have dimensions. Side times side. Side times side, or squared, right? N plus 2 times n plus 2. Side times side. That's the total. Let's look at the number of white dots. Okay, white dots. There aren't any in the middle ever. We kind of pointed it out here earlier. Looks like for pattern 4, there are 4 dots on one side. Pattern 3, there are 3. Pattern 2, there are 2. Pattern 1, there's 1. So it looks like the number of white dots is super related to the pattern number. Here's where the structure of these problems, the structure of these patterns come into play. Yes, this is n number of dots, but how many groups of n do we have? 1, 2, 3, 4. And that's true for each of these. This is n equals 3. Well, shoot, there's our 3 dots. How many groups of 3 white dots do we have? 1, 2, 3, 4. Same here. 2 dots. 1, 2, 3, 4 groups. So if we've got 4 groups of n number of dots, the number of white dots would be 4 groups of those n number of dots. Let's go black dots. Okay, I think some of you noticed. Look, there's always those 4 on the corner. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There's always the 4. So whatever number comes in the middle, whatever that changes, there's always a constant plus 4 at the end for the 4 corners. So what about the middle stuff? Well, let's see. At pattern 1, we have a 1. Pattern 2, we have 4, 9, 16. You're noticing square patterns. You could also think of it as 1 by 1, 2 by 2, 3 by 3, 4 by 4. That's actually n by n, which another way to write that is n squared. There are n squared dots in the middle, plus the 4 corners. Look. 1 squared is 1. There's the 1. And then 1, 2, 3, 4. In the second pattern, n is 2. N squared is 4. Hey, there they are. Plus the 4 corners. For pattern 3, n squared would be 3 squared, or 9. And there's 9. And the 4 corners. There we go. So here's the deal, though. Is this actually true? Is 4n plus n squared plus 4 equal to n plus 2 squared? Like, I would hope so. I would hope that the white dots plus black dots would be all of the dots. Mathematically, we can prove it. Let's simplify this out. I guess we're unsimplifying, expanding it out. If we multiply these together, because it is n squared, which means times itself, n times n gives you n squared. N times 2 plus 2 times n gives you that plus 4n, plus 4 at the end. Hey, that's the exact same thing, except different order, but that's okay. That's the commutative property. We can move stuff around. We got an n squared, we got a plus 4n, a positive 4n, and that plus 4. We're good. Hopefully this helped you out, guys. Remember, this is homework. Come to class with questions next time. Remember, we're mathematicians. We can do anything we want. See you guys later.